Hello everyone and welcome to our practice video for today. So this practice video and other practice videos that I'm going to upload soon is about getting the ratio of in a given right triangle and getting the angle in a given right triangle. So here in this video, we're going to assess our understanding and knowledge about what we have discussed before, which is again getting or identifying the ratio in a given right triangle. So without further ado, let's now begin. True or false? To find the x component and the y component of the radius of the unit circle, we use cosine alpha to find our x and sine alpha to find our y, where alpha is the acute angle between the radius and the x-axis. Let's repeat that once again. To find the x component and the y component of the radius of the unit circle, we use cosine alpha to find our x and sine alpha to find our y, where A is the acute angle between the radius and the x-axis. This is, in fact, true. Okay, this is true. Remember that in a unit circle is centered at the origin. Okay? And the radius of the unit circle is 1 unit long. Okay? So it's 1 unit long. So let me zoom it out for you. Right. So let's just say this is the radius, 1 unit. Okay. So here, there will be always a given angle. There will be always a given angle that is acute. Okay. And in this graph right here, the angle formed between the radius and the x-axis should always be acute. Okay, it will always be acute. And if not, like for example, let's just say I have a another unit circle here, okay, and we have a radius here, and then we have an angle here. Okay, that is not an acute. If that's the case, you're going to find its reference angle. Why though? Why is it that we need to use acute angle? Because there we can find our x component and the y component of that radius. Okay? So in this case, we can find its x component and y component. By how? So let me draw the x component and the y component. In the x component, all you need to do is just use the formula cosine theta. And for your y component, all you need to do is use sine theta. That's it. Okay? In this case, uh, it it uses alpha to represent the angle. So in this case, it's not theta, but rather it's alpha. Alpha, it looks like an A, but in a cursive way. You know, I mean, I'm not good in writing A here. Just pretend that this is A. Okay? So, yeah, it looks like letter D for me. But I think you get the point. This is alpha. Okay, this is alpha. Because I think I mentioned that in one of the last videos about about like angles, if I remember correctly. We can represent angle in different way. It could be a letter, it could be theta, which is usually being used, by the way, or uh, other Greek letters such as this one, which is alpha. Okay? But yeah, bottom line, it is true. To find your x, use cosine alpha. To find your y, use sine alpha. Next statement. Sine function or sine x is equal to the ratio of the opposite to the adjacent side. Again, sine function is equal to the ratio of the opposite side to the adjacent side. The answer is false. Why? Ratio of the opposite side, it's correct, but the other one, it's not. It's not adjacent. Rather, it's hypotenuse. Okay, it's hypotenuse. Not not adjacent. It's hypotenuse. All right? Okay. Next. Cosecant, cosecant or cosecant x is the reciprocal of cosine function or cosine x. Cosecant is the reciprocal of cosine function. The answer here is false. Why false? Cosecant is the reciprocal of sine function. Okay, sine. It's a sine, not cosine. So it's not cosine x, but rather it's sine x. Okay, it's sine x. All right, next statement. The reciprocal of the tangent function or tangent x is equal to the ratio of the adjacent side to the opposite side. Again, the reciprocal of the tangent function or tangent x is equal to the ratio of the adjacent side to the opposite side. This is true. How is it true? The reciprocal of the tangent function. This one, if you're going to write it mathematically, this is 1 all over tangent x. What is 1 all over tangent x? This one is just the same as cotangent x. Okay? 1 all over tangent x is just the same as cotangent x. Okay? And instead of using its reciprocal, equivalent reciprocal rather, we would rather just use its equivalent ratio. And that is what? Adjacent all over what? All over opposite. Okay? So as you can see here, 1 all over tangent x is equal to cotangent x, which is also equal to the ratio of the adjacent to opposite side. Therefore, 1 all over tangent x is just the same as a all over o, or adjacent all over opposite side. So this is, in fact, true. Okay, this is true. And lastly, when the hypotenuse is not 1 unit, it's not 1 unit long, and the given acute angle is given in a right triangle, you will find the x component by using this formula. X is equal to sine alpha and y is equal to h cosine alpha, forgetting the y component, where h is the hypotenuse and alpha is the given acute angle. Again, when the hypotenuse is not 1 unit long and the given acute angle is given in a right triangle, you will find the x component by using this formula. X is equal to h times sine alpha, and y is equal to h times cosine alpha, forgetting the y component, where h is the hypotenuse and alpha is the given acute angle. This is false. Why false? First and foremost, it is almost correct actually. Almost correct. All right? If your hypotenuse is not 1 unit long, what you're going to use? This one, yeah. But there's one thing that is wrong. In getting the x component, we're not going to use sine. Rather, we're going to use cosine. Cosine alpha. Okay? Now, for your y, we will have, instead of h cosine alpha, it's h sine alpha. Okay? Actually, we can use these two formulas in a unit circle actually. Remember that in a unit circle, your radius has 1 unit long. It's 1 unit long, right? And you see, we can get its x component and the y component. So here, we can say that your radius, it's the hypotenuse. So we can use this formula actually. We can. But you see, the hypotenuse of the unit circle, the radius of a unit circle, it's 1 unit long. And remember that in here, the radius itself is the hypotenuse already. Therefore, if we substitute 1 as our hypotenuse, we will have, forgive me, we will have, sorry, technical difficulty. But anyways, we will have x is equal to 1 times cosine alpha. which is just cosine alpha. And y, where would I write? I'll just write it here. And y, uh, anyways, y is equal to 1 times sine alpha. So this is sine alpha. See? So in the unit circle, you can use this actually. Yeah, you can. You can use it actually. There's no problem. All right. But preferably in simplified way, you're going to use this one. This is actually simplified because your hypotenuse is 1. Oh, it's already 1. That's why your h became 1. 1 times cosine alpha, it's cosine alpha. 1 times sine alpha, it's sine alpha. But what if it's not 1 unit long? What if it's 0.5 units, 5 units, 2 units, 100 units? There, you are going to use this one instead. If and only if your hypotenuse is not 1 unit long. Okay? And that will be all.